So we continue the sample survey. Okay, so we ended at the types of errors in a survey. So we said that an error, so from here, an error so we said that an error is defined as, okay, the deviation from the correct or the true value. Okay, so in sample survey or in any survey, it might be that true value you won't be able to capture it correctly. Okay, so the fact that you are not getting the exact value, then we say that error has occurred. Okay, error has occurred. Okay. All right, so there are two types of error that affect the results of what surveys, and these errors are, we have a sampling error and then a non-sampling error. Okay, so we will go through these two types of errors today, right? So the sampling error is a measure of the variability between all possible what samples. Okay, the measure of variability between all possible samples. So this is the definition. This definition are mostly asked in exams, KNUST exams to be precise. What is sampling error? It is mostly asked, so take note. So it's a measure of the variability between all possible samples. Okay, so what happened is that if assuming this is your population, okay, you have 2, you have 3, you have 4, you have 7, you have, let's say, 8, and then finally let's say a 9. Okay, so these are your population: 1, 2, 3, 4, 5, 6 elements, and then possibly you want to take a sample of 3, right? You want to take a sample of 3, so sample, you want to take a sample of 3, so you want to take a sample of 3, isn't it? So that means you have about 6 combination 3 possible samples you can get. 6 combination 3. Okay, this is the number of samples, possible samples you can get. A lot of them, isn't it? A lot of them that you get. So now that you have about 6 combination 3 samples, which is about 20 samples, okay, you will need about 20, you get about 20 samples. All right, so it means that there is a lot of variations, because somebody will pick this and this, different person will pick a different thing, so there's going to be a variation in the estimate that we are going to get. Okay, so the fact that we are not using all the data points here, we are not using all the 2, 3, 4, 7, 8, 9 in our survey, and we are using a sample, we are picking 3 of this. Somebody may come in and pick a different set 3. We expect that there is going to be variabilities, there is going to be differences. Okay, so that differences is going to cause an error, and that error is called sampling errors. Okay, sampling error. So sampling error comes as a result of the fact that we are doing sample. All right, we are trying to pick a portion from a whole. So the fact that you are picking from a portion from a whole, there is going to be variability. depending on what you pick. Somebody might come and pick a different thing, there's going to be difference. Somebody might come and pick a different thing, there's going to be a different. So there is variation, there is changes. Okay, so to capture that changes is the error that we are talking about, the sampling error. Okay, sampling error. So this error only occurs as a result of sampling. Okay, so these errors arise solely from the random sampling variation that are present. Okay, so because you are taking a sample, there's a lot of random sampling. You can sample, if you should do random sampling, you can pick a lot of sample like this. You pick 20 samples, right? There are too many of them. So somebody will pick this 3 pair, somebody will pick this 3, this will pick this 3. There's going to be definitely differences, there's variation. Okay, and that is a sampling error. Okay, all right, so take note of that. So when n these errors occur when n of sample units are measured instead of the complete population of n units. So when you pick a sample, the further you pick a sample, small n from a bigger n, there's going to be a sampling error. Okay, there's going to be a sampling error. Now to measure the sampling error, we need what we call the standard error. The standard error. Okay, so the standard error of a particular statistic, like the sample mean or the proportion. Okay, so the standard error of a particular statistic or the sample mean is a magnitude or is a measure of the magnitude of that sampling error we are talking about. Okay, so now the fact that there are so many possible samples that can be picked, then we'll have to look at the variations. Okay, we have to look at the variations. So that variation we'll be looking at will be captured in the standard error. Okay, that will be captured in the so the standard error will measure that variation, that changes. Okay, the fact that you didn't use all the population but you picked a sample, that your sample may be different from some other sample, so there is that variation changes. We have to capture that variation into a certain error, and then the error, the magnitude, to measure how much of these of that particular error is to use. You have to use a standard error. Okay, standard error to measure that quantity. Okay, so we are saying that standard error is the square root of the variance of the sampling distribution of what? Statistic. The sampling distribution of the statistic. Okay, so when we say sampling distribution of the statistic, like this is, you have 3, you have 4, okay, you have 5. Okay, now let's say this is your population and you want to take a sample of 2. So you want to take a sample of 2. A sample of 2 is what you want to take, right? Means you have 3 combination 2. Okay, you have 3 combination 2. That means you get 3 possible. That means you get 3 possible samples, isn't it? So it means you can have 3, 4. You can also have 3, 5. Okay, you can also have 4, 5. All right, so these are the various samples you can get. Okay, so these are the 3 samples. Okay, so I'm explaining sampling distribution of the statistic. Okay, so when I use this sample to find the mean, now I want to look at the mean, assuming this is max. Okay, they got in some exams which is over 5. Okay, over 5. So these are the max 3 students got and it's over 5. Okay, so I want to find the mean of the population, the mean mark of these 3 students, but I pick a sample of 2 instead of picking the 5. Pick a sample of 2. So I'm trying to find the mean of this. Okay, that means I'll have I'll have 3, okay, 3 plus a 4, okay, divided by a 2, okay. So that value I'll get will be my first value. So let's call this sample I. So sample 1, for sample 1 I got a mean of 3.5. For sample 2, when I add and divide by 2, I'll get a mean of a 4. And then my sample 3, when I'll get, which is 4, 9 divided by 2, which is 4.5. Okay, 4.5. So when I am done, these values, 3.54 and then 4.5, will become these are the x bars. Okay, so this is x bar 1, x bar 1, x bar 1, and this my x bar 2, x bar 2, and then my x bar 3. Okay, so these guys you see here are my statistic. This is a statistic, this is a statistic, this is a statistic. So but they are different. Okay, they are different. So even though I'm trying to find the mean of this distribution by picking a sample of 2, but I see there are variations in it, there are changes. Okay, so I have to find a way to get a distribution for this. Okay, so to get a distribution for this, I'll use a discrete distribution. So I will say, okay, this is my x bar. Okay, x bar, then I'll draw a line. So x bar 1, which is, and then I'll look at the probability of x bar equal to small x bar, x bar equal to small x bar. Okay, and then so here this value here is 3.5. How many times is it appearing? It's one time. It's only there once. Okay, and how many x bars do I have? 3. So means the probability here is 1. Probability here is 1 over 3. Okay, and then the next one is 4.0. okay, so 4.0, the probability there is also 1 out of a 3. Okay, and then the other one too is a 4.5. okay, 4.5, and the probability there is also 1 out of a 3. Okay, so this distribution you see here, let me clear this guy. So this distribution you see here, okay, this distribution you see, which is a discrete distribution, is what we are saying that this is the sampling distribution of the statistic. Okay, so what you are seeing here is a sampling distribution of the statistic. So the sampling distribution of the statistic is what you have seen here. This is a distribution, it's a discrete distribution. So now you can find the variance of this distribution. Okay, so you remember, if you are finding variance, you have to find first moment, second moment of this. This is a discrete distribution, right? So that variance you get when you take square root, that will be the standard error. Okay, so you use this to find the variance, and then you take square root, that will be the standard error. Okay, so that is basically how if you want to understand sampling distribution, okay, of a statistic. So the statistic here was the mean, okay. So that is exactly what it means, okay. So the fact that because you can see the fact that I picked a 2, I was having different means. That was not so there's an error. So you have to look at the variations, the changes that is happening within this, okay, and that is captured in this probability distribution. So finding the mean of this probability distribution will the variance of this probability distribution will give you the magnitude of that variation, okay. All right, so we have non-sampling error. Remember, before that, let's talk about something here, okay. Look at this carefully. Now, if what you do to minimize that error, so what you will do to minimize the error is to increase the sample size, okay. So if you have 2, 3, 4, 5, 6, 7, 8, 9, if you have this 1, 2, 3, 4, 5, 6, 7, if you pick a sample of, let's say, 3, the error will be bigger than picking a sample of let's say 4 or 5, okay. So if you want to reduce the error, that magnitude of the error, you want to reduce it, you have to increase your sample size, okay. So increase the sample size and then you reduce the error, okay. So that is also the typical objective question, okay. So you increase the sample size. When the sample size is sufficiently large, the sampling error are reduced, okay. So take note of that. All right, so non-sampling error, these errors occurred not because of sampling, okay. The sampling error is not about sampling. It doesn't deal with picking a sample from a portion or something. This is just a general errors that may occur. Maybe coding, people gave you wrong answers, people didn't respond to the questionnaire, they didn't want to give you the information. So anything that will cause an error that is not due to just picking a portion, okay, from a whole, okay, that is what it means to assess non-sampling error. So a non-sampling errors are any phenomena other than sampling errors that cause a difference between a parameter and its estimate, okay. These errors or bias do occur at all stages of the planning and conduct of a survey. They really pose much danger to the survey. As a result, their magnitude is typically, okay, much larger, and there is no satisfactory theory or technique measuring the size of these errors, okay. Of course, you can't measure the size because some enumerator went somewhere, they didn't give you the correct something, you can't even figure it out, okay. During the coding they made a mistake, that one is there, people don't respond to the questionnaires, all right. There are so many things that can happen, and you can't quantify the magnitude of such an error, okay. So there is no technique to measure that error, and then it's basically caused by the following. I've mentioned some sampling operation, okay. All right, so problem of non-response, people didn't respond to the questionnaires, they are hardcore, they don't want to willingly give you the information you need, okay. Like lack of knowledge and understanding of the survey concepts, okay. So probably the people you picked to take the information have no idea how they can take the information. Even those you are asking them, they don't know what you are trying to ask from them, right? Concealment of truth, if they fear that probably they are giving you the information so that you will use it against them, they will not give you the right information, they will even tell you the information, all right. There are a lot of them, okay. You can go through improper design of questionnaire. You didn't design questionnaires well. The questionnaires ask questions that respondents cannot even answer. You won't get the required results. And then measurement error. The person's height is 17. You made it 170. Typical error. When you calculate your stuff, you will get that error, but you can't quantify that error. All right. Wrong processing of data. Inadequate supervision. You didn't supervise well. All right. You would, so Non-sampling errors, if you want to reduce it, then opposite of that, proper design of surveys, reduction of non-response rate by substitution, right? People didn't respond. Now this guy didn't respond, one guy is there. So if Kofi didn't respond, you can put Ama there for Ama to answer the questionnaire so that you won't miss out. Okay, if you didn't prepare your design, or you didn't design your surveys very well, you have to redesign it. Okay, all right. Good design of questionnaire. Your questionnaires, make it well. Don't give in difficult questions that make people boredom and stuff. Make sure your questions are interesting for people to ask. Pilot surveying. Now pilot surveying is all about doing a survey before the main survey. Okay, doing a survey before the main. So before doing the survey, just take your questionnaires out, let some few people answer them so you can see the mistakes and then in the questionnaires, so that when the main survey comes, by that time you have rectified all your issues. Okay, that is pilot survey. And then post enumeration survey, when you are done with the main survey, you want to do another survey to check out the potholes and fill the potholes. Okay, that is the post enumeration survey. So all of these can be done to reduce the error that happens as a result of non-sampling technique. Okay, all right. So that is basically the two types of errors we've discussed today. All right, so go through again, post your questions, we are there to answer for you. Okay, so we'll do the next topic very soon. Okay, so watch out.